All right. Hey, Algebra 2 Trig Honors. Hope you're enjoying your remote learning day. Hopefully you got a chance to sleep in. And as promised, I'm going to walk you through this example on the back side of our second handout from class on Monday. So let's go ahead and take a look. Calvin and Holly visit the children's ward at the hospital. The probability that Calvin will catch mumps as a result of the visit is P of C, 0.13, and the probability that Holly will catch mumps is P of H, 0.07. And we're going to consider that C and H are independent events. First of all, if I want to find the probability that Calvin does not catch mumps, I'm going to use that idea of the complement. So the probability that he does not catch mumps, we could think of Calvin not catching mumps as C prime, or not C, is 1 minus the probability that he does catch mumps, or 1 minus 0.13. So the probability that he does not catch mumps, 0.87. Similarly, the probability that Holly does not catch mumps, we'll call that P of H prime, or not H, 1 minus P of H, which is 1 minus 0.07. So the probability that she does not catch mumps, 0.93. The probability that both Calvin and Holly do catch mumps, so we want to know the probability that Holly catches mumps and Calvin catches mumps. Because we know that C and H are independent, we know we can just take the probability that Holly catches mumps, multiply it by the probability that Calvin catches mumps, and in that case, we get a result of 0.13. I should do it in correct order. 0.07 times 0.13. The probability that they both catch mumps, 0.0091. Next, we want to find the probability that neither Calvin nor Holly catch mumps. So in this case, we want another and probability, but this one is going to be H prime and C prime. And once again, because these events are independent of one another, we can use the property that we can multiply to get that probability. So the probability of Holly not getting mumps, we calculated that in part B, that's 0.93, multiplied by the probability that Calvin does not get mumps. We found that in part A, 0.87. So the product of those probabilities, 0.93 times 0.87, is 0.8091. That is the probability that neither Holly nor Calvin catch mumps. Let's pause for a second and look at what those probabilities are. If we think about each of them has a pretty high probability of not catching mumps, so it makes sense that we have an 80% chance that neither of them will catch mumps. Alternatively, since both of them have a reasonably low probability of catching mumps, 13% and 7%, the probability that both of them catch mumps should be relatively low. And then finally, the probability that at least one of them catches mumps. Well, there's two ways we could calculate this. We could calculate this by finding first the probability that Holly catches mumps and Calvin does not, plus the probability that Calvin catches mumps and Holly does not, plus the probability that both Holly and Calvin catch mumps. But that would require us to have calculated all three of those. So far we've only calculated one, and then add them together. The more efficient way is to say, well, the only time that not at least one of them catches mumps is D. So the only time that we don't want is the one we found in part D, when neither of them catch mumps. And if we take 1 minus that, 0.8091, we are left with 0.1909, and that's the probability that at least one of them will catch mumps. That includes the probability that Holly catches mumps and Calvin doesn't, plus the probability that Calvin catches mumps and Holly doesn't, plus the probability that they both catch mumps. Hopefully this will help you. Go ahead and finish working on both the homework assignments from day 3 and day 4. I'll see you on Thursday, and of course we'll spend time answering questions, doing some more practice, and making sure we are comfortable with all of our properties of probability. And do me a favor, bring in a good joke, or at least one that you like, on Thursday.